All right, one-sided limits. You've probably already seen these in class, but I just want to point out how to work them. And then also, we'll start off by just showing you, hey, the notation's a little bit different. So if you look at this little limit problem right here, it's the same as the ones we've been looking at with one exception. See this minus sign right here? Maybe too small to see very well, but there's a little 2 with there's a little minus sign to the right side of the 2. That does not mean -2. It's not a typo. What it means is, so this is going to be the limit as x approaches 2 from the left. And the reason that's a minus sign is because, you know, when you're on the number line, it's the numbers off to your left that are the negative numbers, and then the numbers off to the right are the positive numbers, or the bigger numbers. That's what's saying. So that's the reason negative sign is approaching from the left, or coming this way, it's from the left, is what the minus sign means. Plus, now you notice 2 plus doesn't mean anything, right? 2 is already positive. But plus on the right side of the number means we're approaching from the right side. And then if there's nothing over there and it's just x approaches 2, that's what we've been doing to this point, and that is just approaching from both sides at the same time. So the default, if there's no negative sign or plus sign, meaning from the left or from the right, if you just see a limit as x approaches 2, you're supposed to assume that it means both at the same time. That can be a big deal though, because it's going to turn out that there's a rule where the two sides have to match in order for this thing to exist. So a lot of functions, it's like if you're coming from this direction, your limit will be this y value right here. If you're coming from this direction, it'll be this y value down here, because we have two functions that don't line up. So the limit from the left and the limit from the right will both exist, but then the limit from both sides won't exist because they don't match up. They have to match up for there to be, for the limit to exist from both sides at the same time. So that's just a nitpicky rule. I'll keep mentioning that because it's such a nitpicky rule and it's really important, you know, in terms of like not missing problems. So we'll keep it up. All right, so let's just do some examples and we'll get some practice with that as well. All right, so the limit of f of x as x approaches 1 negative, so from the left. All right, so what we do is we go to our graph here, say, all right, we're approaching 1 from the left. So which one of these lines, you know, here's x equals 1, so to approach from the left, I'd be having to drive along this road. I sort of have two options. You know, I gotta be driving along either this road or this road. I have to be driving along the function. If I'm approaching from the left, I pretty much have to take this one. So if I'm driving along this, you know, I'm going from like x equals -2, x equals -1, x equals 0. I'm almost to x equals 1. What does it look like I'm going to hit? You know, if I'm just going along like this, where does it look like I'm going to land? I'm going to land right here, right? Happens to be an open dot, but that's where I think I'm headed. So my limit approaching from the left is just 1, because that's the y value of that open dot. But if I'm approaching from the right, as indicated by this 1 plus, that means I'm coming along this way, down this road, and it sure looks like I'm headed for this point right here. And what's the y-coordinate of that point? It's 3. All right, so the limit from the left and the limit from the right don't agree because these two things are backwards, or they don't line up. They're like this. So yeah, if you're coming from this road, that's not a head-on collision. That's just two totally different destinations, right? And that's why we got two different numbers for the left and right-sided limits. The limit as x approaches 1, now you'll notice there's no plus or minus after this 1. That's the limit, like the limit. So that's the one that doesn't exist in this case. Because the left one and the right one don't match up, they're going to miss each other, that means that there's no limit, so the limit does not exist. So ironically, even though the left and the right both exist on their own, because they don't match up, the limit, the big limit, does not exist. And last little question is to keep our function notation straight. What's f of 1 in this one? F of 1 is like, I need the closed dot. Empty dots don't cut it for f equals 1, so for f of 1. So the question is, at x equals 1, what is the actual value of the function? We got to go up to the closed dot, and that's 3. So it turns out the limit from the left is 1, the limit from the right is 3, and f of 1 is also 3, because that's where we have our closed dot. If we'd been really crazy, we could have had open dot here, and closed dot somewhere else. And then we would have gotten three different numbers, 1, 3, and whatever that value up there is 5 or something for the f value. All right, crazy stuff. Don't worry, we'll get more practice on this. Now here's a really crazy one. 3 different chunks, 2 open dots, a closed dot. It's crazy, right? Let's see what happens. All right, so in this one we've got, first of all, I'm asking what's the limit as x approaches -3. That's kind of small. So as x approaches -3, and there's another minus sign, meaning from the left. All right, so -3 approached from the left. Well, here's -3, and if we're approaching from the left, that means we have to be coming down this guy. So we're going, woo. Where does it look like we're going to end up at x equals -3? It looks like we're going to end up at this hollow point, right? So that is, drawing's a little off, but it looks like that's y equals 1. So that means our limit as x approaches -3 from the left, coming down this guy, it looks like we're headed for this point, which is y equals 1. What happens when we approach? No, we don't have from the right. All right, so next one, x approaching 2 from the positive direction. All right, so here's 2, and it's got a little plus behind it, meaning we're approaching 2 from the right. So we're coming x this way, which means we have to be going up this graph right here, and we're headed towards that point right there. So what point does it look like we're headed for as we approach this dot? Well, it looks like we're headed for the dot, which has a y coordinate of 1. So our limit approaching 2 from the right is 1. All right, next one. Limit as x approaches -3. Now this negative sign is in front of 3. So that doesn't mean from the left. All that means is -3. All right, so that means we're looking at this little point again at x equals -3. So this time it says, what's the limit as x approaches -3? There's no right hand or left hand little nonsense after the -3. It's just -3. So that means what number is being approached from both the left and the right? So the problem we've got is that these two don't line up because they're headed different places. They're going like this and like this, but they're going to miss. They're above each other. If they had collided at some point, we'd be like, oh, the limit is just that y coordinate where they're about to hit. But since they miss, we got left-handed and right-handed limits that don't agree with each other. No limit, does not exist. Pretty exciting. All right, limit as x approaches 2. All right, so we already figured out what happens when x approaches 2 from the right. That was 1. But this doesn't have a right or left on it. It doesn't have a plus or minus after it. It's just as x approaches 2. So that means I need both the left and the right to agree. I already know that the right-hand limit at 2 is 1, because as I come along here, it looks like I'm headed for right there. But now I need the limit approaching 2 from the left. Well, it turns out these actually line up, right? Because we have two functions coming up like this and then an open dot. But the point is they're coming to the same point. They're coming, it looks like they're going to collide. So that point they're going to collide at is y equals 1. And that's why the limit as x approaches 2 is 1. Because both sides approaching look like they're going to collide at y equals 1. And the last one, there's a little curveball I just threw in at the end to keep you on your toes. As x approaches -1. Well, once again, we've got a -1 without any plus or minus after it. But when we go to look at -1, aren't we like, oh, there's -1. It's like, oh, here we are. We're right there, right? So we're just in the middle of a curve. We're not at one of these funky boundary regions where we're going from open dot to plus dot and all that kind of junk. It's just the middle of a curve. All you do is just plug in the number. At x equals -1, y equals -3, right there, and we're done. So whenever they sort of drop a curveball on you and just make it almost like too easy, sometimes they do that just to mess with you. They give you an easy one to screw you up instead of giving you a hard one to screw you up. But it's kind of funny, you know, they'll drop in the easy problem amongst the hard ones, and all of a sudden that becomes the hardest problem on the test. All right, one more funky one. Now you can see on this one we got an open dot, we got a asymptote, which means, you know, this thing is shooting off to infinity and stuff. Pretty crazy, but we're just going to follow our rules. Left-handed, right-handed, and then if you want, you know, neither left or right, they got to match up. So let's take a look at it. First one we want is x approaching -3 from the left. So here's -3. If we're approaching from the left, we're coming across along this guy sideways, and it looks like we're about to get to that open dot point, which is at -3, 1. So the y coordinate right there, 1. So it looks like as we approach -3 from the left, it looks like we're going to get y -1. Do we actually? No. But that's what it looks like. All right, so that was from the left. What happens when we approach -3 from the right? Well, let's see. Approaching -3 from the right means we're coming along this way. Oops. To get -3 from the right, I'm actually driving this way along this crazy curve. But just when I thought I was headed -3, it takes a kick to the north and just goes up crazy. So what does that mean? that it's kind of like headed towards infinity, right? Because at -3, this thing doesn't exist. It's going to infinity. So that's a DNE. There is no limit because the function is increasing without bound, without any limitations, going straight up. So anytime you feel like if you had plugged in that number, you would have gotten infinity, or if it's on an asymptote or something, does not exist. All right, limit as x approaches -3. There's no plus or minus after this thing. There's no left-handed or right-handed aspect. So that means that left and right would have to agree as we approach -3, but they don't. Because approaching from one side, I got -1. Approaching from the other side, I got do not exist, or basically infinity. And obviously -1 and infinity do not collide. Therefore, I got does not exist. So this function does not have a limit at -3. What is f of -3? Well, it's not this point because that's an empty dot. The only point, there is no point on -3, it turns out. It's undefined. And that is because we're on an asymptote, and an asymptote never gets crossed, which means there's no point sitting on the asymptote. So anytime the point they're asking for would be on the asymptote, it's just undefined. And finally, limit as x approaches 1. See, there's another curveball. If you just looked at this last problem, it's actually pretty simple because just x approaching 1, well, hey, look at that. That's over in the middle of nowhere. It's in the middle of a curve. So the limit is just the y-coordinate, which happens to also be 1. So the answer to that is 1. All right, so pretty wacky. On these one-sided limits, you just got to really keep track of whether you're coming from the left or from the right, and most students get that pretty well. What really burns you, and the thing you got to always remember, is if there is no left or right hand thing, if it's just a number that you're approaching, that means you're assuming that you're approaching from both directions at the same time. And if those things have to line up perfect, if they just miss by a little bit, or one's coming down like this and one's going up like that, doesn't matter. Unless they meet perfect, the limit does not exist at that number. They've got to line up perfect.